Okay, hello everyone, welcome back. So this is the first video where I'm really going to actually analyze some data using Python. And so I've called this one, you can see the title there, Common Analyses 1, Descriptive Statistics. So I'm starting with descriptive statistics because I thought it'd be kind of a nice gentle introduction. Really, and I think people often like it when they quickly can learn how to do something and make it work, and obtaining descriptive statistics using the different software libraries in Python is pretty straightforward. So I thought I'd start with this rather than kind of tidying up data wrangling, data cleaning and munging, because that can often be a little bit more complex and frustrating. But we'll go on to those sorts of things next. So in this particular video, and using the notebook that I've got open on the screen, I'm going to demonstrate how to obtain some descriptive stats using various software libraries in Python. These will be the descriptives will get are the usual most common measures of center or location, so the mean, the median, the mode, and also measures of spread, so variance and standard deviation. But I'll show you how to obtain kind of some more robust measures of spread. Um, the sorts of, so we're doing the sorts of things you typically do when you first get hold of a data set. You have it in the format that you want it in. You kind of start to look at it visually, and you start to obtain some descriptive statistics, see if you can summarize the data in some way. Okay, so the first thing we're going to do really, the first thing we really need to do is import certain software libraries into Python. And key ones of interest here are NumPy, which stands for numerical Python, pandas, which stands for panel data. So this kind of is built on a base of NumPy, and it's a really useful software library. It allows us to create kind of like data frames of a similar nature to the sort of thing you're probably used to seeing in Excel. In addition to that, I'm going to import some a software library, matplotlib, which is useful for creating data visualizations, histograms, and the like. We'll get a couple of histograms out of the data set we're using in this, and I'm also going to import. I'm importing a software library called SciPy, which has a lot of statistical functions in it. I don't think we'll actually need them in this case, but I'll import it anyway in case we do. So you can see there in this first cell that's highlighted in blue, um, it's a convention in when using Python to import certain software libraries that you're going to need, and to save you typing out their names every time you want to call a method or function from that library, you give them a nickname. So you can see there we've got import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import scipy.stats, so the various stats methods from scipy. We're going to import them as stats, and so every time now that I need to use one of those, I can refer to it using this nickname that it's been given. So I'm going to execute that first cell. Make sure my kernel's not gone to sleep. There we go, it's working. And that's imported those different software libraries that we're going to make use of in this case. So if I move on to the second cell, number 2, so what we're going to do is import a data set that's saved in a folder on my computer, and we're going to save it as a Python object. A common convention is when people import data sets is they'll save them using the name df, short for data frame. What I'm going to do is I'm going to save it as a Python object. So I'm going to save it as a specific object. I'm just going to call it weight, because it's a data frame that's about weight, and it records weight and various other variables in relation to some participants. And I'm going to import this data frame using pandas. I'm going to call pd for pandas dot read underscore csv. So it's saved as a comma separated value file in a folder on my computer, and I'm basically in the parentheses, in quotes here, you can see I've just specified the name of the CSV. So weight data.csv in these quotes. So it's saved the quotes and where it's highlighted in red here. This is a string. This is something I'll create another video about, different types of objects and things you can have or use in Python. But if I run this particular cell, we have just imported dataset and assigned it the name weight. Okay, so that particular dataset that I'm using, I'm not sure where it came from. I'm not sure who first recorded it. I believe I might have first played around with it, doing data analysis on it, as part of a free and open course on how to do data analysis using R, put together by Daniel Nettle at the University of Newcastle. So I just thought if that is the source of this data, I don't know where they got it, whether he got it from somewhere else, but if that is the source, I just thought it's probably best to acknowledge that. But that's the data we're just going to use as an example here. So we've now just read the CSV file. Pandas has read that, and we've assigned it to a variable called weight. Okay, and we can then invoke. We can check that it's been imported correctly by invoking this head method, where we just specify the name of the data frame weight dot head with 2 parentheses, and that gives us the head of the data frame. So if I run that, you can see the first 6 lines. So you can already see these cells that have been populated. I could have reset them, I guess, before recording this video. I was thinking about live coding this, but I thought it would make the videos much too long, and also you would get to see how many errors I make when I'm coding things. So the different ways that I do things in these videos using Python, such as when we get onto data cleaning and tidying data sets up and manipulating variables in different ways, there are probably much better ways to do them than the ones I use. I'm kind of focused more on finding a solution that works. There's probably much more elegant ways to do these things, much more Pythonic ways. And you could probably go on Google and search on Stack Overflow and find much better ways of running these types of things, or doing the various things that I do in these notebooks. But if my view is, if you're kind of learning this stuff and it works, you're having some success at least. So what you can see here is you can see the first 6 lines of this notebook, of this particular data frame about weight, and we've got a number of variables. So we've got a sex variable, which is male, female. Age is an integer. Leg length is obviously some sort of measurement of how long the leg is. Height, measurement, some sort of scale measurement. Weight. And then we've got this like subject ID, so that's probably a participant unique ID number. And it's also the date frame, as it's got this unnamed 0 here, which is obviously some sort of index that was attached to it. But where we've imported it, Pandas has given us its own index, so 0. Notice as well in Python that things are 0 indexed, so the first entry is indexed as 0. Okay, so we could have, another method we could have used here is, I'll do it now. If we use the kind of, the dot tail method, this will give us the last 6 lines of the data frame. Yeah. The default value is it gives you. Let's go back to the head. It gives you 6 lines, but you can specify how many you want by putting the number in parentheses. So if we ask for the first 3 lines of the header, that's what we'll get. But we'll go back to the default for now anyway. But so we can see the data is imported. Well, if I could create another cell below this, and we could ask weight.info. That's quite useful to look at, because you can see if we use this .info method on our data frame, it will tell us each of the variables we've got, how many non-null values there are. So that data frame has 50 participants, and we can see that there's 50 non-null for each variable. If some of these, if say age had 45 non-null, we know we'd have 5 missing values for that particular variable. And we can also, most importantly, we can see the data type we've got, and we can see that as you'd expect, some of these values, such as age, are integers, and some of them are decimals, or what in Python are referred to as floating point numbers. So the ones that are kind of saved to decimal places are floating point numbers. And importantly, if we look at sex, this is a categorical variable. It's saved as an object, so these are string values. It's worth keeping that in mind. If we were going to do some sort of statistical manipulation on that, we'd need to code that in some way. Okay, so useful to know to use this invoke this info method. It can tell us a lot of information of things we might need to tidy up in our data. It's pretty good in this case because we don't have any missing values. And all of the data types, usually pandas, when you import a data frame, it will identify the correct data type. So for sex, it's correctly identified that that's a category and saved it as an object. Age, it's saved as an integer value. Leg height and weight is saved as decimals, floating points. But sometimes it doesn't, and often it's the case that people will use dummy codes for categorical variables, and you might need to manipulate and play around with it. But let's just start with obtaining the mean for each of these variables. So we could just use this dot mean method and call it on the whole data set. So weight dot mean, and it's given us a warning message that in future this is going to be deprecated, this method, but gives us the printout. So it's telling us the mean value for each of our variables. So for some of these variables, such as that unnamed index variable and the subject ID, this is quite meaningless data, really. We can't really have the mean value of a subject ID, I don't think. It has no point to it. You can't really do any statistical manipulation with it. But we are probably interested in the mean weight value, the mean height value, mean leg length, and the mean age of participants in our data set. So those are kind of the types of descriptive stats we might like to obtain. And then we could also do the same with median. So if we use this dot median, invoke this dot median, we can see there, it gives us the median value, and interestingly they're quite close to the mean, so not much difference between them for all those variables that we might be interested in. So we could say, another thing we could do, we could have done it with, if we just wanted the mean for a specific variable, or the median for a specific variable, we could actually just tell Python which variable we're interested in. So from the weight data set, if I put brackets after weight, and we say we're interested in the mean age, and I would then put in quotes age, and it's spelled, notice I've spelled it with a capital A because that is the way it's saved in the data frame. You want to make sure it is saved the same way. And if I close the brackets, all we're doing here is we're using the weight data frame. We're just asking for specifying we want the age variable, and we're invoking this mean method again. And if I run that now, you'll see it just returns the mean age. And we could have done the same here with median for age. Okay, so that's a kind of quick and easy way where we can just call these methods on our data set and get stats out, descriptive stats out quite quickly. I shall change that back. Let's run that again. Okay, say we wanted to select individual columns or variables from a data frame, we could create a new object with those because we were just going to manipulate them, and then if we do anything to those, we're kind of not changing our original data frame. So if we were just interested in age, so as I did above, I'm just specifying I want the age variable from the weight data frame, and then we're going to assign this to a new to be a new kind of variable type of object, a new object, and that's going to be some type of numpy array. And if we then use the head method on ages, it'll give us the first few. Notice that it's not as nicely presented in HTML as our pandas data frame was, with the bold headings and index numbers and things like that, because it's now kind of just a vector of numbers effectively, and not a it is a panda series, but it's not a nice data frame. Okay, but then we can still do the same sort of analysis just on that new object that we've created. So we wanted the mean age, the median age, we just call those same methods on that new object we've created. So what if I'm interested in getting descriptives for multiple variables in our original data frame? So I could create a new object like we just did for ages, with a kind of useful name, for which just contains the variables that I'm interested in. So out of our original data frame, there are only 4 really that are kind of interest, and those are those scale variables for weight, height, leg length, and age. The other 2 were just kind of like index sort of numbers and participant unique reference numbers, really. What we can do is we can create a sort of new pandas data frame with just the variables of interest by creating a new object. I've given it the name weight underscore scale, so it's the scale variables from our original weight data frame, and that consists of the variables that we want to extract from our weight data frame, our original data frame that we imported earlier. And notice I've passed a list of the 4 variables that I want, and it's in double brackets. So when you have brackets and a number of strings, or it could be numbers, integers, floating point numbers in Python, that signifies a list. And notice how I've passed a list in into this as an argument. Okay, and if we run this, you don't see any output because I didn't ask for the head, so I didn't ask it to display anything. But that data frame has now been created in the background, and this is the big difference there, I think, when you're working with programming languages like Python and R that people have to get used to. Or one of the differences is you're kind of not looking at your data all the time. You're manipulating it in the background. But if we ask for the head of this new weight scale data frame, then we can see this. So we could just then use these same mean and median methods on our new reduced size data frame, and it gives us the measures of center that we're interested in. So we might also want to select specific rows from a data frame. For example, we might want to filter our data frame so it only contains certain groups, certain categories, certain values. So for example, let's say we wanted to we just wanted to do some analysis on participants who were older than 30 years old in our data set, and we could create a new data frame object called above underscore 30. I gave it that name. That's it. The name was chosen by me just so I can remember what it's about. And what we're going to do is we're going to get our original data frame weight, and then from weight we're interested in the weight age variable, and we've set up this inequality here saying greater than 30. So if I run this, what that's done is now create a new object, and if we call the head method on this above 30 head object, what you can see is we've now got a data frame with the variables in, all the variables in, but it only contains participants whose age is above 30 years old, so 31, 32, 33, 33, 36. And you can see which participants have been missed out based on their index number. So those participants 1, 2, 3, 4, 5, 6, 7 are all missing from the data frame. This isn't the full data frame. We could just, if we remove the head and if we just call that, we can see that this is how many participants are older than 30 in that data frame of like 50, so there's probably about 12, 14 people there. I'll reduce it back to the head though, just to save space. Okay, so we imported matplotlib as well, which is a visualization plotting software library that we can make use of, and we imported it as PLT, gave it the nickname PLT. So there are lots of different methods you can use to plot data, but obviously a common one when you're first sort of investigating variables is you often want to know how they're distributed. So we can obtain a histogram using matplotlib for, say, the ages variable, and remember we created ages as a separate object up here. And if we use this call plt.hist for histogram, and then in parentheses we just pass the name of the object and run that, you can see it creates this histogram for us, so we can see how the variable is distributed. So it looks like we've got quite a lot of people around 18, early 20s, and then it's sort of quite a weird distribution, quite positively skewed. Okay, so let's do something similar. Just playing around with it, I'm going to create a separate object that just contains the weight variable. I'll call it weighs, and then we'll get a histogram of weights as well. We could have, to obtain this, we could have just passed this. I'll copy and paste into here. It would have returned the same thing. Okay, but I just wanted to show that you can, it's often more convenient to just create new objects and manipulate those objects. Okay, so alternative ways to obtain the mean and median. We can use numpy directly. So remember, I imported numpy as np, and if we use the print function and pass numpy.mean and the variable or the object that we want the mean of, same np.median, same sort of thing. So lots of different ways I've demonstrated so far, and we can also obtain the mode. And remember, we can, if I run this, you can already see it, but it will just produce the same. We can see, remember, we can have multiple modes for a variable. So for example, leg length has 4 modes below. You can see here we've got a number of people had a leg length of 104, 104.6, 104.9, 110.2. So a number of people had those, the same number of people had those 4 leg lengths, and they were the most common. We can see here we've got quite a few people were 19, quite a few people were 20 as well. So it gives us the mode. Not the most useful measure of location, but I guess it can be at different times. All right, so I'm conscious that this video is already getting a bit long. So I'll move on to measures of spread, and we'll kind of move through these as quickly as we can. So one of the most basic measures of spread is just the range. So that's like the highest value, subtract the lowest value from the highest value in your data set, and it tells you the range of scores. So if we use our weight scale, data frame, the height variable from that, we could use this function max and pass in height from our weight scale data frame, and then subtract from that min. So that's kind of quite useful. If I run that, all we've done is all it's done there is it's basically a pandas function, and it's taken the max height and subtracted the minimum height for it to give us a range. So the range is 32.5. There's a range of the range from the lowest to the highest height is about 32.5, whatever they likely to be centimeters, I imagine. But it could be inches, I suppose. We can also get like a 5-number summary of given percentiles by using this dot quantile method for a variable. So notice that first I've created a new object. I kind of like doing this a lot of the time. I created a new object called 5num for 5-number summary, and then I'm going to call it using that object name, so we can see what the output is. Here we're going to use this dot quantile method, and we're going to basically ask for the minimum, the maximum, and the 25th, the 50th, or the median score, and the 75th percentile for weight, for our weight variable. If I run that, you can see, so we've got a 45.5 is the minimum weight, 101.6 is the heaviest person, the median is about 66.55. If we went back and looked, I won't do it now, but if we scroll back up and looked at the median for weight, we'd probably see that is the same. But there's an easier way, so that's kind of like involves a little bit of typing on our part, really. Notice here it's in brackets, I've specified the data frame and the variable of interest, and then the method I'm using, and I've separated each one by a comma. So each output is separate, each part of the output is separated by a comma as well. But there's a much more convenient way to do it, and that's just using this dot describe function. And what this does, it'll return the same 5-number summary that we just obtained there. This one. The min, 25th, 50th, 75th, and the max value for a variable. But it also gives us kind of the count, the number of data points for the variable, the mean, and the standard deviation as well. So if I run that one for height, you can see there are 50 participants, mean of 169.57. And if we do the same, use this dot describe method for weight, what we will see there is the same 5-number summary, one matched the one that we did here, which was a bit more laborious and time intensive to work out. Okay, so having these, using this quantile method, it can be useful for other things. So if you want to obtain the interquartile range, that's obviously the difference between the third quantile and the first. So 3 minus 1 essentially, and we can set that up as a little calculation and obtain the output. So all we're doing here is specifying the data frame and the variable of interest, and then we're saying we want the value that's at the 0.75, the 75th percentile, and subtracting from that the value that is at the 25th percentile. That'll give us our interquartile range. If we run that, as you can see there, we've got an IQ of about 14.20. Yeah. So those are things that we might be interested in, but much more commonly used measures of spread are the variance and standard deviation, certainly when we're doing these sort of frequentist type of statistical analyses. So similar to using for the mean, the median, the mode, we can obtain the variance using this dot var method. Yeah, so if I run that, you can see we got a variance of 147.67 ish, and underneath we've got the standard deviation, and that's just the call for that, or to invoke that, I think is the correct language. We're just going to use this .std and then some parentheses. So let me run that cell. You can see we've got 12.15 is our standard deviation. Obviously, if we squared this, we'd probably find we got this value for the variance. Okay, so if we wanted a more robust measure of spread, we can calculate the median absolute deviation, which is quite interesting. So we're not sort of squaring things like we do for the variance. We're just taking the absolute value of all deviations from the mean and from the median, sorry, and I've set up this little equation here. So the median absolute deviation, and I'm going to use this absolute value function here from pandas, and what I've passed into it there is the kind of median from our weight scale, and then subtract every data point. So it's going to take the absolute value of all these deviations here and create it as a new object. So effectively that would be a vector. If we obtain the printout for abs median deviation, that'd be a vector of deviations. But what I've done instead here is I've taken that new object without obtaining an output of just a big list of numbers, and then I've taken the median of those deviations by using dot median. And what we see is we've got a median absolute deviation of 6.75 ish. Okay, so last couple of things before we finish. Perhaps we might want to know what the skew is for a particular variable, or the kurtosis. So remember, skew is kind of how far our variable deviates from kind of being normally distributed. Has it got a long tail? Is it to the higher numbers? Is it positively skewed, or is it negatively skewed? That's got like a long tail towards the lower end. So this is going to give us an actual value, a number. And generally what we're saying is skewness will be close to 0 for a normal distribution and close to 1 for a heavily skewed distribution. So if we look at how skewed our weight variable is, we see it's got this we've got this 0.59. So it's closer to 1 than to 0. And if we go back and look at weight, the histogram for weight, there we go. We can see that it's got a little bit of a tail going off to the higher numbers, so it's slightly positively skewed. Okay, and kurtosis, we can do the same for kurtosis. We'll get some sort of value for kurtosis. So a normal value will have a normal distribution for a variable will have a value closer to 0. And kurtosis, if you've studied this stuff before, it relates to how flat or peaked the distribution is. And a highly peaked distribution will have a higher or greater kurtosis value. So if I run this for the weight variable, we see we get an output of 0.10. So it's quite close to 0. And if we look at that variable distribution of that variable again, yeah, you can see it's not really thin and peaked, and it's not like really wide and flat. Yeah. Okay, this was longer than I intended, but hopefully it was useful, and just a quick introduction. So I've done the same thing a number of times here. I've shown you how to import some useful software libraries, import data from a CSV. Create a data frame using pandas from that, and then interrogate in various ways, such as obtaining the mean, the median, the mode, creating different objects from it, creating reduced data files where we're just extracting certain variables, and even filtering a data frame by groups that we might be interested in. Then we looked at some measures of spread. Robust ones, starting with basic ones like the range, interquartile range, obtaining some robust ones as well using the median absolute deviation, and then the kind of standard ones we often use, such as the variance and standard deviation. Okay, I'm gonna stop there. Next video, I'll go on and start talking about how to wrangle data using pandas. So we get it into the sort of format that we want it in, so we can conduct different statistical analyses.